Welcome back, guys. In this video, we are going to continue our discussion of the use of mole-to-mole conversion factors. And in this video, we're going to specifically explore how we can use the mole-to-mole conversion factor to essentially take us from a mass of a given amount of reactant, in this case C4H10, and determine the mass of another reactant, or another product, in this case, water. So we're going to use the combustion reaction, a combustion of butane, C4H10, right, of course, in the presence of oxygen, forming CO2 and water, to essentially answer the question. If we start off with now 225.0 grams of butane. In the previous videos, we've started off with moles. In this case, we're going to have a certain mass of butane. We want to figure out what mass of water, okay? So we've got a mass of butane, we want to figure out the mass of water. So proceeding as we did before, we're going to start off by writing down, of course, what we're given. C4H10. Now, this is in grams, so we need to somehow figure out how we can end up at the end of the day in grams of H2O. But we can't convert directly as we did in the previous slides. So in the previous example, we would have written something like this, figure out how many grams of H2O. It's very tempting for students at this point to just come in and say, well, hey, I know based on my stoichiometric coefficients, right, that I want to convert, of course, over here to grams of H2O, and I want to get out of units of grams of butane. So can't I just go ahead and use those stoichiometric coefficients, 10 and 2 in this case, plug them in directly, and then carry out my conversion? Well, the answer is no. Do not do this under any circumstances, right? The reason being that these balanced chemical reaction equation, these stoichiometric coefficients in this balanced chemical reaction equation represent the number of molecules or the number of moles of molecules, not grams. So we are in units of moles when we're actually looking at our balanced chemical reaction equation. So when we are pulling off these stoichiometric coefficients, these coefficients correspond to molar quantities, not gram quantities. So what we have to do here is, of course, take a little bit different approach. We're going to use this mole-to-mole ratio here, but before we can apply the mole-to-mole ratio, we need to first convert the given quantity here in grams. We need to convert that to moles. So we need to get to moles of C4H10. Once we're in moles, then we can convert from moles of reactant to moles of product. And then we can carry out our final conversion here, which we'll write down here, to get to grams of H2O. All right. Now, good news, we already know how to carry out these conversions, grams to moles. Right? Converting a certain mass of substance into the number of moles of that substance is accomplished by using the molar mass. In this case, the molar mass of butane here is 58.12 grams. And as I mentioned in the previous video, whenever we write down a certain quantity, a certain unit, I want you to tack that unit onto whatever molecular species we're talking about. In this case, we're talking about butane, so I'm going to write grams C4H10, right? So there is, for every 1 mole of C4H10, right, that mole weighs 58.12 grams of grams. And so basically, we're going to do that for each one of these moles to grams conversions. In this case, we're dealing with the molar mass of water. But now we want to convert from moles of water into grams. So we're going to want to put the grams quantity up top. And the molar mass of water is, we can basically round it off. We'll go like this, 18.02 grams of H2O for every 1 mole of H2O. So those are our molar mass conversions. And then, of course, what's left to do is just the same thing that we've done in the previous videos. We want to come up with our conversion factor that takes us from moles of butane, moles of our one reactant, to moles of our other reactant here. And in that case, we're going to be ending up in moles of H2O. We want to cancel out our moles of C4H10. And for that, we will use those stoichiometric coefficients. So we'll put a 10 down there and a 2 right there. Okay, so putting all of this together, we're going to start off with our given amount of reactant. We're then going to use that molar mass, this guy right here, and we're going to convert to moles of C4H10, which essentially amounts to dividing by that molar mass that we obtained from the periodic table, adding up the contributions for every one of the little species, elements involved in building up that compound. Now we're going to carry out our mole-to-mole conversion using the stoichiometric coefficients from that balanced chemical reaction equation. Looks something like this. And so now we've used this conversion. Now we want to end up at the end of the day. Remember, our goal here is to determine what mass of water can be produced. So to determine the mass of water, we need to convert from the units of moles of water to mass of water. Carry out like this, which should give us a value of about 348.8 grams of H2O. So we see what the general formula that we're following here is just as we did in the previous videos. We're using the stoichiometric coefficients to convert from the amount of one reactant to the amount of product that we're forming. But before we can apply that mole-to-mole conversion, it's imperative that you remember we have to use those, the molecular weight, the molecular formula, the formula mass rather, in order to convert from the mass units, given mass units, into the units of moles, so we can apply that mole-to-mole conversion. And then at the end of the day, we use the molecular mass once again to convert back into our desired units of mass.